Here we have a problem on derivative. So there is a function given over here and we have to find dy over dx. That is, we have to find the derivative of this function with respect to x. Okay, here on the right side of the given function we have natural logarithm, and also here we have terms are multiplied, and also we have exponents over here. So before we find derivative, we can use the properties of logarithm to split up the stuff we have on the right side. So when we split up the stuff over here on the right side using the properties of logarithm, so the process of finding derivative will be easier. Okay, so first let me use the properties of logarithm. So because ln stands for the natural logarithm, its base is e, and here so e to the x power and this quantity, the two terms are multiplied over here. So in a logarithm, whenever two terms are multiplied in the argument, what we can do is we can take a logarithm for each quantity and add them. So this is the product rule of logarithm. So now I'm going to take natural logarithm for this term and add them. So then I'm getting ln e to the x power positive ln of x negative 2 over x positive 2 to the power of 3/4. Okay, so I just use the product rule of logarithm. So I take logarithm for this one and this one, added them. Okay, in the next step, what I'm going to do is I'm just going to use the power rule of logarithm. So whenever the argument of a logarithm is an exponential term, so the exponent we have in the argument can be moved in front of the logarithm and it has to be multiplied by the logarithm. So this exponential x can be moved in front of this logarithm, then I'm getting x times ln e positive. So the same thing, the exponent over here can be moved in front of the logarithm. So actually this is the power rule of logarithm. So then I get 3/4 times ln of x negative 2 over x positive 2. Okay, so in the next step, y is equal to x times. So here, whenever we have the spelling ln for logarithm, it's called natural logarithm and its base is e. So in this logarithm, the argument is e, the base is e. So in a logarithm, if the argument and base, both of them are equal, the value of such logarithm is just 1. So the value of this ln e is just 1. So x times 1 positive 3/4. And here in this logarithm, we have two terms are in division. In the argument of the logarithm, we have two terms are in division. So we can use the coefficient rule of logarithm. In the argument of logarithm, whenever we have two terms are in division, we can take logarithm for the numerator and denominator separately, and we have to subtract them. That's a coefficient rule of logarithm. Then I'm getting ln of x negative 2 negative ln of x positive 2. Okay, so that's all. I think we can do one more step over here. Y is equal to x times 1 is just x positive 3/4 times ln of x negative 2 negative ln of x positive 2 over here. Okay, that's all the properties we can use over here. I mean, properties of logarithm we can use in the given function. So in the next step, what we can do is we can find the derivative. So when I find derivative of this y with respect to x, I'll be getting dy over dx. And the derivative of this x with respect to x is just 1 positive. And here in this part we have variable over here, so we have to consider the whole stuff we have in the square bracket as variable part. So this variable part is multiplied by the constant 3/4. So when I find derivative, if a variable part is multiplied by the constant, I have to keep the constant as it is and find the derivative of variable alone. So I'm going to keep this constant 3/4 as it is. So because 3/4 is multiplied by this variable part. Now I have to find the derivative of this variable part. So let's find the derivative of this first natural logarithm. So whenever I find derivative of natural logarithm, what I need is I have to write 1 in numerator and in denominator. So whatever stuff I have in the argument of the logarithm. So here the argument of the logarithm is x negative 2. It should be taken in denominator. So this is the derivative of this natural logarithm. Okay, by chain rule, I have to do further derivative for the argument over here. So what is the derivative of this x negative 2 with respect to x? So when I find derivative of this constant 2, it will become 0. And the derivative of this x with respect to x, it will just become 1. So we have to times it by 1, negative. And now again we have a natural logarithm. When I find derivative of this natural logarithm, I have to put 1 in numerator. And whatever stuff we have in the argument of the logarithm, it should be taken in denominator. And now by chain rule, I have to do further derivative for this argument x positive 2. So when I find derivative of this constant 2, it will become 0. The derivative of x with respect to x, it will just become 1. So we have to times it by 1. Okay, now we have to simplify this one. Dy over dx equals to 1 positive 3/4 times 1 times 1 is just 1 over x negative 2 negative 1. 1 times 1 is 1 over x positive 2. Okay, so we get dy over dx equals to 1 positive 3/4 times So here we have to subtract these two fractions. Actually, these two fractions do not have the same denominator, and also the denominators contain variable. So whenever I want to add or subtract two fractions where we have variable in denominator, so it's a bit difficult to find the least common multiple. So how can we subtract these two fractions? We can use cross multiplication. So what is cross multiplication? The numerator 1 over here has to be multiplied by this denominator x positive 2. So I'm getting 1 times x positive 2, and whatever sign we have between the two fractions should be taken as it is. This numerator 1 has to be multiplied by this denominator. Then I'm getting 1 times x negative 2 over, I have to multiply the two denominators, so I'm getting x negative 2 times x positive 2. So dy over dx equals to 1 positive 3/4. So 1 times x positive is the same stuff, x positive. When I distribute this negative 1 to x and negative 2, I'll be getting negative x positive 2 over. So this is in the form of a negative b times a positive b. So there is an identity in algebra. That is for example, whenever we have whenever we multiply two binomials in the form a negative b and a positive b, it will result a square negative b square. This is one of the basic algebraic identities. So here instead of a in our problem we have x, for b we have 2. So for a square negative b square, what should I write? I have to write x square and negative 2 square. So this positive x negative x will cancel out. So I'm getting dy over dx is equal to 1 positive 3/4 times. So when I combine this 2 and 2, it will become 4 over x square negative this 2 square will become 4. So this 4 goes into 4 one times, 4 goes into 4 one times. So dy over dx equals to 1 positive 3 times 1 is 3 over x square negative 4. Okay, now I have to add a fraction and an integer. So whenever I want to add a fraction and an integer, what I need to do is I need to multiply the integer part by the denominator of the fraction. So once I'm done with this multiplication, I can take this stuff as a common denominator. So when I multiply this 1 and x square negative 4, I'm getting x square negative 4, and we have positive sign, and we have 3 over here. So once I'm done with the multiplication of this 1 and x square negative 4, I can take this x square negative 4 as a common denominator. This is an easy way of adding an integer and a fraction. So in the final step, dy over dx is equal to, so x square, when I combine negative 4 and positive 3, I'm just getting negative 1 over x square and negative 4. So now I got the derivative of the given function. The derivative of the given function is x square negative 1 over x square negative 4.